So this question comes from 3.5, it's number 15, and it says to determine the points in the interval from 0 to 2 pi at which the graph of the function f here has a horizontal tangent line. So in order to find that, what we have to do first is take the derivative. So I'm going to take the derivative of 6 cosine x, and I will get 6 times the negative sine x. And then 3 sine of 2x, the derivative of that will be 3 times the cosine of 2x, and then times d over dx of 2x. So this will be negative, cleaning this up, negative 6 sine of x plus 3 cosine 2x, and then the derivative of 2x will be 2. So now I want to set this equal to 0, and I'm going to say negative 6 sine of x plus 6 cosine 2x is equal to 0. And then from our trig identity, so we have to have our trig identities handy. This is the cosine double angle formula. And I'm going to use, it looks like this, and I'm going to use a cosine double angle formula. When I look those up, so you have those to reference. And so I can replace the cosine of 2x with 1 minus the sine squared of x. So I'm going to put that in place of this. So that, again, that comes from the double angle formula. So I'm substituting in 1 minus 2 sine squared of x. And so now I'll distribute that 6 to obtain 6 minus 12 sine squared of x. Now I can factor out a 6 here. So I'm going to factor out a negative 6. And let's see what I get. Sine of x minus 1 plus 2 sine squared of x. Divide both sides by 6, negative 6. And I can write this in descending order to look like this. And now I have something that I can factor. So I'm going to say let, substitution here, let sine of x equal u. So in place of the sine of x, I'm going to plug in u. Well, I shouldn't say I can factor it. I shouldn't say I can solve it for. So now I'm going to check, can I factor this? Possibly. Can I do factors of negative 2 that add to 1? And yeah, there are factors of negative 2 that add to 1, I think. So let's see. Yep. So I could factor this. There are many factoring methods. The one method that I teach is called the slide and divide method. So I'll show you this. But we can also use the quadratic formula. Slide and divide method says that you slide the a value down, and you slide it down to c. And we get this, and then we factor this, because when a is 1, it's easier to factor. So I'm going to say factors of negative 2 that add to positive 1 look like this. Then I slid that 2 down, so I have to divide it out. And so if I can simplify, I do so, and I get u plus 1 times 2u minus 1, because this one does not simplify, so I'm going to slide it back in front. And now the factored form of this, I gotta substitute back in, and I'll get sine of x plus 1 times 2 sine of x minus 1. So here I've got the factored form. Now, if you don't want to factor, you can also use the quadratic formula at this point. So let's just do that off to the side. So if you have 2u squared plus u minus 1 equals 0, you can say a is equal to 1, b is equal to, a is equal to 2, b is equal to 1, and c is negative 1. Quadratic formula, let's remind ourselves what it looked like. Opposite of b plus or minus b squared minus 4ac over 2a. So plugging those in, I'm going to get the opposite of b plus or minus b squared minus 4 times a times c, divided by 2 times a. So negative 1 plus or minus, underneath this square root symbol, I have 1 plus 8, so that's 9, divided by 4. So I'll have two answers here, negative 1 plus 3 over 4 and negative 1 minus 3 over 4. This will simplify to 2/4 or 1/2, and this will simplify to negative 4 over 4 or negative 1. So those are the x values, which is the same thing that I'm going to find here. So solving this, I use the zero product rule, and I get sine of x is equal to negative 1. And here I get 2 sine of x equals 1, but divide both sides by 2, and you get 1/2. So find the same thing either way. This, you would say this, I said x values, I meant u values. So, and then when you substitute that back in, you end up with the same thing, right? So now we have to find the x values. So this is doing it with the quadratic formula, and this is factoring. So now we have to find what values is this going to be between 0 and 2 pi. So let's think about that. On the, where is the sine of x equal to 1/2 between 0 and 2 pi? That's at x equals pi over 6 or 5 pi over 6. And I'm going to grab the unit circle to kind of show you those two. So here's a unit circle. 1/2 is the sine value is the y value, so 1/2 pi over 6. And there's also 1/2 here at 5 pi over 6. Then also we want to know where is the sine of x equal to negative 1. So we're looking at the y values. It's negative 1 at 3 pi over 2. So we're going to put here x is equal to 3 pi over 2. So now we've got the x values, and we'll find the y values by taking and plugging in those values into our function. So we've got f at pi over 6. We're going to have f, we're going to evaluate it at 5 pi over 6. And we're going to evaluate it at 3 pi over 6. So the function, the original function, let's grab that. The original function is 6 cosine x plus 3 sine 2x. So 6 cosine x plus 3 sine 2x. So I'm going to put in here pi over 6, pi over 6. And so evaluating that, I'm going to give myself some room. If you are to put these in your calculator, you want to make sure you're in radian mode. The cosine value at pi over 6 is square root 3 over 2. And I should say multiply that by 6. And then this will be the sine of pi over 3. And so pi over 3, the sine value at pi over 3 is this. So now, simplifying this, I'm going to get 3 square root 3 plus 3 square root 3 over 2. And then I need to, actually I shouldn't have simplified this yet. I need to be able to combine the denominators. So 6 over 2 is the denominator. So 9 square root 3 over 2. So that's going to be my first, well, one of my points. And it tells you in the WebAssign that you need to go from smallest to largest. So pi over 6 comma 9 square root 3 over 2. And it wants it in exact form. So you don't want to give a decimal approximation. You want to make sure that you put it in exact form. So this would be my first one. That's my solve. So then I'm going to do the same thing with each of these. So let's do our next one here. So filling in my angle now. This time I'm using the angle of 5 pi over 6. So the cosine value at 5 pi over 6 is negative square root 3 over 2. And the sine value, remember, you're going to, this is 2, and a 6 down here, it becomes 5 pi over 3. And 5 pi over 3 is in quadrant 4. And the sine value is square root 3 over 2, negative though. And so when I go to simplify those, I'm going to get negative 6 square root 3 over 2 plus 3 square root 3 over 2. So I'm going to end up with negative 3 square root 3 over 2 for my answer. And so, oh, error there. This should be a plus sign. So this is minus. So this would be negative 9. So put that in the WebAssign, and you'll get, and you should have 5 pi over 6, comma, negative 9 square root 3 over 2. That's the second one because 5 pi over 6 is smaller than 3 pi over 2 if you look at the unit circle. And then the last one, and I wrote this wrong, there should be a 2 here. So 6 cosine so we're plugging in 3 pi over 2. Pi over 2 is that on the unit circle it's 270. So that's 6 times 0, and 3 times the sine of 3 pi. 3 pi is coterminal with 180 degrees or pi, so that'll be 3 times 0 also. And so we'll get 0 here. So that last point you're going to record as 3 pi over 2 comma 0.